Good morning, friends. So here we are again. So we have just completed the types of graphic representation. So in which we have seen the four types of graphic representation. The first one is a histogram. Then the second one is frequency polygon. The third one is frequency curve, and the fourth one is scatter or dot diagram. So all these graphic representations are actually used the group data information to plot a graph. So now let's have a look at the merits of graphic representation and as well as the demerits of this graphic representation. So first let's see the merits of graphic representation. So it is easily understood by all. So when we actually our grouped data information, actually it is in the very large amount, and when we put this information in the form of diagrammatic representation, so it may be a histogram or it may be any diagrammatic representation. So this is actually makes easy to understand all the informations. So that's why it is easy to understood by all. So the data can be presented in a more attractive form. So with the help of these different types of methods, that is different types of graphic representation, we can represent our information in the more attractive form, so that the interested persons or peoples could read and understand it easily. So it shows the trend and tendency of values of the variable. So it shows the specific trends of the information. So when we put our information in the graphic representation, actually it shows a trend that how the information is actually how the information showing that how the given data is actually increasing and how the data is actually decreasing. So we can also compare the information between the variables. So this is also very important point. So the diagrammatic representations are useful to detect mistakes at the time of data computation. So when we plot or draw a graphic representation or a graph, we can actually detect that um, some mistakes that we done actually collecting our information or actually doing our experiments. So this is also a very good important merit of this diagrammatic representation, that we can actually detect our mistakes. So it shows a relationship between two or more sets of figures. So it is also useful to make an a relationship between the sets of figures, or also between the graphs we can also make a relationship. So it has the universal applicability. So it is also a good merit of graphic representation. So it is helpful in assimilating the data readily and quickly. So we can assimilate our data readily and very quickly with the help of this graphic representation. So now let's have a look at demerits or limitations of this graphic representation. So it does not show or all the facts. Okay, so when we draw our graph, so it only have a two axes, that is x and y axis. So we can use only these two points to represent our information. So the all the details of the group data information we cannot put into that graphic representation. So this is a limitation or demerits of this representation. So the graphic representations can reveal only the approximate position. Okay, so it also reveal only approximate position. So again, this is one of the demerit, and then it takes a lot of time to prepare a graph. Yes, of course, these group data information, actually when we want to draw a graph, then it will take a lot of time to prepare a graph. Okay, so these are some demerits or limitations. So this is about the graphic representations of, that is merits and demerits of graphic representation. So now let's have a look at this diagrammatic representation of data. So the first diagrammatic representation of data is a line diagram. So this is the line and diagram. So this is one of the diagrammatic representation of data that we can used to represent our group data information in the form of line graph. So let's see the line diagram. So it is the most common method of representing statistical information, mainly used in business and commerce. Okay, so this method is actually used in this business and commerce industry. So these are drawn on the plain paper by plotting the data concerning one variable on the horizontal x-axis and the other variable of the data on y-axis, so which intersect at a point called origin. So it is similar to that of that graphic representations, that is histograms and frequency, polygon and curve and all that. So the effect of one variable upon another variable during an experimental study may be clearly demonstrated. So again same, in this case also the effect of one variable, we can compare these variables between them and can be clearly demonstrated. So according to data for corresponding x, y values, we will find a point on the graph paper. So the points thus generated are then jointed by pieces of straight lines successfully. So the figure thus formed is called a line diagram. So it is somehow this line diagram is actually a combination of, we can say that it is a combination of scatter or dot diagram and the frequency polygon. So in case of frequency polygon, we join the histogram with the straight lines, and in scatter or dot diagram we actually only putting the dots. But in case of line diagram we actually putting a dots, and as well as we are joining these all the dots with the help of straight lines. So this is the line diagram. Now let's have a look at example. So the data of effect of practice on learning are given in the table. So the effect of practice on learning, the data is actually given in this table. So this is the trial number and this is the score. So in the first trial, the score is 4, then second trial the score is 5, and on the third trial the score is 8, and like that the trial number 12 having a score of 16. So with the help of this information we have to draw the line diagram. So when we want to plot the graph, we actually combine these points, that uh, we have to put the points on this with the help of this information, that is 1 4 2 5 3 8 4 8 5 10 and up to the 12 16. So on the x-axis they will be our trial, on the y-axis will be our score. So uh, first just dot, we have to put a dot on the graph, then we can uh, join these dots with the help of straight line. So this is how we can draw our line graph. So now let's have a look at second type of diagrammatic representation, that is bar diagram. So uh, if we look at the diagram of bar diagram, this is how we can see, or we can draw our bar diagram. So now let's see the bar diagram. A bar diagram is a graph on which the data are represented in the form of bars, and it is useful in comparing qualitative or quantitative data of discrete type. Okay, so this bar diagram actually useful to represent our data, and it is very useful in comparing the qualitative and as well as quantitative data. So this is the important point. So it consists of a number of equally spaced rectangular areas with equal width and originate from a horizontal base line. So the length of the bar is proportional to the value it represents. So again somehow little bit similar to that of histogram. So they are shaded or colored suitably. Okay, so in this bar diagram actually the rectangles are actually colored or shaded. So the bars may be vertical or horizontal in a bar diagram. So in case of histogram, the rectangles are without shaded or colored and the bars are actually vertical. But in case of bar diagrams, the rectangles could be vertical or could be horizontal. So there are three types of bar diagrams. So simple bar diagram, then multiple or grouped bar diagram, and subdivided bar diagram. So Actually we are not going to see all these three types of bar diagrams in detail. So let's have just look on this simple bar diagram, so showing weight in kilogram among boys and girls. So this is the weight which is represented on the horizontal line, that is 20, 40, 60, 80 and 100. So this is the bar for the weight of boys, and this is the bar for weight of girls, and the bars are actually shaded. So this is how we can draw our bar diagram. So now let's have a look at third type of diagrammatic representation, that is pie diagram. So in the pie diagram we actually using a circle to represent our uh, information. So let's say it is a circular graph whose area is subdivided into sectors by radii in such a way that the areas of the sectors are proportional to the angles at the center. So the area of the circle represents the total value, and the different sectors of the circle represent the different parts. So it is generally used for comparing the relation between values, so it gives comparative difference at a glance. Then in pie diagram the data is expressed as percentage. So whatever the information we have to convert it in the percentage form, and then we can only use these percentage data to represent our pie diagram. So the name of the pie diagram is so, because in determining the circumference of a circle we have to take into consideration a quantity known as pi. Okay, so when we uh, put our information in the circle, we actually need to take in consideration the quantity, that is pi. Okay, so we have to consider these points, and then only we can put our information in this circle. So let's see this example. So if we have example, that is construct a pie chart for following data. So the principal exporting countries of cotton in 1955 and 56. So we have some countries. So the first one is United States of America, that is USA, then India, then Egypt, then Brazil and Argentina. Okay, and this is the exporting quantities of these countries. So um, again we want to make a table. So this is the table for country, and this is the exporting quantities and the converted percentage. Okay, so if we want to convert the into percentage, then we have this we have to sum all the quantities, and then we can get the total of export, and this is the 100%. Okay, so how can we get this 54%? So simply we need to divide these quantities, individual quantities, with the total quantities into 100, and then we get this percentage. So if we'll take an example of this USA, so 6367 is divided by this 11906 into 100, and by simply calculation we can get this 54%. So similarly in case of India, these 2999 is actually divided by this 11906 into 100, and then we will get this value, that is 25%. So after getting these values, okay, now we have to put these values into this circle. Okay, so how we can put these values? So simply we have a circle that consists of a 360 degree. Okay, so 360 degree, and now we have a total percentage, that is 100%. So simply 360 divided by 100, so 3.6 degree actually. Okay, so the 3.6 degree represent the 1%. Okay, so I hope you are getting this point. Okay, so the 3.6 degree actually represent the 1%. So simply we can multiply this 54 into 3.6, and whatever the degree we get, we simply draw these points. Okay, so this is the pie chart showing principal exporting countries of cotton in 1955 and 1966. So this is also a kind of representation, a kind of diagrammatic representation. So this is about the pie diagram, and thank you all. And uh, so we have completed this chapter. So I hope you all are found these video lectures informative. So uh, thank you, and thank you.